Okay, thank you for joining us. First of all, I'd like to apologize for the interruption in the class for today in the morning. I had a complete network shutdown. I couldn't even join the class. So that's why we have tried to arrange for this class so that we can compensate the time that we lost in the morning, though time cannot be compensated. When you lose time, it can never be a bought back, but we're trying to cover up things that we needed to discuss in the morning. Yeah, so we were looking at sensitivity and the specificity. That was our topic in the morning before network cut us down. Yeah. So I want to go back to what we were trying to look at in the morning. So there are some people who are still joining. So I'm trying to admit these one that are joining us. Okay. So I'm going to share the screen. Just help me to confirm when you see it. Okay, so we have started sharing the screen. Just confirm if you can hear me and see the screen that is being shared.
Yes, we can hear you and we can see the screen.
Okay, wonderful. Yeah, so we were looking at the sensitivity and the specificity. So, who remember the definition for sensitivity and specificity? What is the difference? What is sensitivity and what is specificity? Madam Bridget.
Let someone help me now. Come in late.
Okay. Yeah, so we're trying to differentiate specificity from sensitivity. So remember, we started by looking at screening. So when we are screening, we are using a test that will help us to identify those people that are at the likelihood of having the disease or not having the disease. Okay, so now we talked about some of the criteria that we should consider as we are doing this screening. So one of the criteria that the test that is used should be valid. That means it should be able to measure what it has to measure. So when we come to this test, when we are doing screening, the test that we use can identify those people who have the disease, and it can identify those people who do not have the disease. But it is not 100% that it will be able to identify all the people with the disease and also identify all the people without the disease. So sensitivity refers to the ability of the test to identify people, to correctly identify people with the disease, while specificity refers to the ability of the test to correctly identify people without the disease. Okay? those are people who test negative. So now, in our test, it is possible to have people who have the disease, but when we do the test, the result come out to be negative. Okay? It is also possible to have people who do not have the disease, but when we do the test, the result come out to be positive. Okay? But they don't have the disease. Okay? So that's where now we have the issue of true positives. True positive are those people who test positive when they have the disease. Then we have true negative. True negative are those people who test negative when they do not have the disease. Okay? Then we have false positive, which are those people who test positive when they do not have the disease. The true negative are those people, the false negative, I mean, are those people who test negative when they actually have the disease. So I've talked about how to calculate these in our morning session, where we said if we have 10 people, okay, or where we identified this formula to use when we are doing the test. These are the formulas that we can use. Yeah? So sensitivity is given by this formula, which is sensitivity is equal to true positives divided by true positive plus false negatives. Then specificity is equal to true negative divided by true negative plus false positives. Okay? Let me admit, show people from here. Yeah. Okay. We have true positive. Sensitivity is equal to true positive divided by true positive plus false negatives. So this simply means that we want to find people. Out of those people with the disease, how many people can be correctly identified as positive people? So now I was giving an example where you have maybe 10 people who have malaria and they come to the hospital. Okay? From these 10 people, we do the test, and our test is able to identify only 7 people to be positive. So that means we are going to have 3 people who are going to be negative. Okay? Who are going to be false negatives. These people have the disease, but they are going to test a negative. Then, when we calculate the specificity, okay, just a minute. Direct. Yes. It's 30 kwacha, 30 kwacha. That's why it's 60. Yes. For lunch. Yes. Yes, direct. Okay, now the challenge is that I'm on a trip. When I'm home, I have already bought food home. But here I have to add to what Mr. Mwinga is having. Then when I'm out, no, it's okay for those one if the company can't manage. Yes. No, it's okay if the company cannot budget. I was looking at maybe I have to help here and also when I'm out there. Yes, yes, yeah. Okay, director, it's okay. Hello? Okay. Hello, can you hear me?
Yes.
Okay.
Yes, sir. We can hear you, sir.
Okay, so I was presenting on this thing that we had already discussed in the morning. I hope maybe we are clear on this one so that we can go forward. Is it clear on how to calculate specificity and sensitivity? Or maybe there's someone who was left behind during the morning session.
Yes, on specificity.
Okay, so I think let me go to specificity, looking at the time so that we don't waste much of time here. So specificity, we said these are people, the ability of the test to identify the true negatives. Those people who do not have the disease, then they also test are negative. Okay, so now to calculate this one, you need to know how many people do not have the disease. Okay, and how many people out of those that do not have the disease, how many people are going to test negative. Okay, there is a call that I'm trying to avoid. Let me just tell this person that I'm in class. Director. Okay. Okay. Yeah, I have from Monday to Tom. Mm. Okay. 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 Sorry for that. Trying to avoid the call, but it keeps on coming and disturbing. Yeah. So we're saying that first you need to know the number of people who do not have the condition that we are looking at. So I was giving an example of maybe you have 12 people who come to the health facility. They say we have malaria, when actually these people do not have malaria. So what are we going to do? We have to calculate the specificity of this test. So we are going to count the number of people that are going to test negative and the number of people that are going to test positive when they don't have the disease. So the number of people who test negative, they are called true negative when they don't have the disease. So we are first going to identify the true negative out of these 12. So I was giving an example that, for instance, we have 8 people who test negative, okay, when they do not have the disease, and the test come out correctly to say that these people are true negatives, 8 of them. Then we have 12, okay. Out of 12, when we subtract 8 from 12, these people are going to test positive. There will be 4 of them, okay. Then now, when we come to this formula, the true negatives, how many are true negatives here? From this example that I've given, how many are true negatives? Hello? How many true negatives do we have here? Are people able to get me? 8.
Yeah, 8.
So our true negatives is going to be 8. Okay? Divide by our true negatives, it's 8 again. Plus, how many are false positives here? How many false positives do we have? Hello? You're trying to say something? Please go ahead.
4.
4. Yes. 4. So we are going to have, now we're going to have, I'll go on top here to write on top since there is no space this side. We are going to have specificity is going to be 80 divided by 4 plus 8 is what? Is 12, right? Then you can multiply this one by 100. Okay? So what is 12? 8 divided by 12? Let's do mathematics. 8 by 12 is giving us what? 0.66. So when we round off, when we multiply by 100, this means our specificity is going to be 66%. So that means out of people who do not have the disease, this test is going to correctly identify 66% of them as true negatives. Okay, it's going to correctly identify the true negatives, 66% true negatives. Okay, so that is how we find the specificity. Okay, any question on this one?
Yes, I have a question.
Yes.
Okay,
Yes, go ahead.
we are getting it.
Sorry?
I'm asking to say, where are we getting the 100? Because on the formula that is being shown there on the screen.
Okay. So specificity and sensitivity.
Are you there?
Hello, can you hear me?
Yes.
Specificity and sensitivity, these are normally expressed in percentages. I don't know if we are together on that one. These one are normally expressed in percentages. So you have to convert them to percent, because when you look at this 0.66, you cannot tell what they mean. Okay? Is it clear?
Yes, thank you.
You're welcome. So we go to the next. So this one is just an example telling us that if you have 80%, 88% sensitivity, this means that 88% of people with the disease will be correctly identified. Okay? So 88 of the people with the disease will test positive. That's what actually it means. It means that 88% sensitivity means that 88% of people with the disease will test positive. Meanwhile, we know that the other 20 what? 88 minus 100 minus 88 is what? Is 22, right? So 22 of them are going to test uh, negative when they have the disease. And how can you classify this one? Hello? How do you classify those who have the disease by the test negative?
They are false negatives.
Yes, they are false negative. So 22% of them are going to be false negatives. Then you have 80% specificity. It means that 80% of the people without the disease will be correctly identified, or 80% of the people without the disease will test negative. That means 20% of them are going to test positive when actually they don't have the disease, and these are the ones that we call false positives. Okay? So now, let's look at the relationship between sensitivity and specificity. I don't know if there is any question on the previous uh, uh, slide. Any question? So, when we look at the relationship between sensitivity and specificity, is that for the same test, if we are using one test, that same test, if we are to increase one, okay, if we increase maybe sensitivity of that test, that means we are going to reduce it, automatically reduce the specificity of that test. Because what happens that when you increase the sensitivity, the test now will start identifying people, okay, as positive, even when they don't have the disease, will be identified as positive, okay, because the test will become very, very sensitive, okay. So you need to decide which one is more costly, either to have false positives or false negatives. Which one is more costly? Okay. So what you need to know again, what happens when you have more false positive, and if you decrease um, false negative, the test is going to be more sensitive. So now, from your experience or from what you think, which one is costly, to have more false positive or more false negative? Which one is costly?
I think the false positives.
Okay.
The false negatives, sir.
The false negatives. Why?
Because those are
So what is wrong with that?
In case, okay, so someone comes to the clinic and then they are diagnosed wrongly, they are given a negative instead of the positive, which means those people will not be treated. They'll go home and the disease will be progressing. It will become worse.
Exactly. 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 So people have come to the health facility and you tell them that no, you are not sick. They will go home without being treated. And the more you delay, the more the condition becomes worse. The disease will keep on progressing because it has not been treated. Those who are saying that it's good to have false positives, more false positives, what is your reason?
Me, I'm saying more positives is expensive because you'll be trying to treat the patients who are not sick. Instead, you are wasting jobs instead of treating those people with true positives. So I feel it's more expensive because you are just wasting the resources when you are not treating anything. So like you are wasting the resources. That's my reasoning.
Interesting. So all the answers actually are valid. All these one are expensive. I have seen another hand, Madam Felistas. What do you say on that one?
I actually wanted to say both of them are what can I say? Both of them are a risk, like the way you wanted to explain.
Yeah, both of them are the risk, but we need to weigh now. Which one can we go for? Okay? Because again, maybe when we are just waiting resources, it's good because maybe we're just wasting money than allowing the disease to progress because at the later time we are going to lose people. But either ways, both are costly because again, when we are looking at in the situation where we have limited resources and we are busy treating people who are not sick, okay, or maybe we need people to come for the retest because they have tested positive and we are not sure if the sensitivity is too high. We need to do the retest. So we are going to have a lot of people again coming for the retest instead of having just few people. So both are costly, but when it comes to this, we need to make a decision because you cannot just leave it just like that. So you need to make a decision which one you are going to go for. Okay? Yeah. So here what is written that false positives are associated with cost emotional. Okay? False positives are associated with cost emotion. Imagine someone comes to the health facility and you say you have cervical cancer. Okay? That is going to cause emotion stress to tell someone that you have survived cancer. And it will be very difficult for you to tell that person actually that you don't have. Okay? Okay, it will be very difficult to tell those people. Again, false positives um, also pose a major burden on the healthcare system in that a large group has to be brought for retest uh, instead of a fewer group. So just like I was saying, if you have more people that test positive, we need to do another test. So we're going to have a lot of people, which is going to waste resources. Okay, then false negative will be told they have no disease and will not be followed of which serious disease might be possibly missed at an early stage. That just like what the other colleague was saying, we are going to miss the stage at which we can treat this disease effectively. Okay, so both they have problems, there are consequences for both. Okay, then we come to predictive value of a test. Okay, predictive value of the test. So we have this one. Predictive value simply means uh, how many people who test positive actually have the disease. Okay, or how many people who test negative actually don't have the disease. So we have the positive predictive value and the negative predictive value. Okay? The positive predictive value and the negative predictive value. So the positive predictive value is going to be true positive divided by true positive plus false positives. Okay? True positive divided by true positive plus false positives. Who can notice the difference between predictive value, positive predictive value, and sensitivity in terms of the formula? Who have noticed the difference? Hello?
From what I've observed with the positive predictive value, we are only dealing with positives.
Yes, we are only dealing with the positives here.
Yes, the formula has true positive plus the false negative,
Yes,
but yet the false positive.
yes. So the formula differs here. We have the true, the false negative there. Here we have the false positive. So we're only dealing with the positives. That is a positive predictive value to identify how many people who test positive actually have the disease. So when we're looking at people who test positive, we're looking at there is including of people who are false what positive here. So we just want those who test positive, who actually have the disease out of all of them who test positive. How many have the disease? Okay, that is the difference. So given this positive test result, what is the likelihood that the patient has the disease? That is the positive predictive value. Then we have also the negative predictive value, where we are looking at everyone who tested negative. Okay, how many of them are actually negative or do not have the disease? So we are looking at the negatives only, those who test negative. So we have the true negative and the false negatives. Okay, so we are given this example here where we are saying a screening test is being done in a certain country D for the disease J. The test kit has sensitivity of 80% and specificity of 78, so no, 85%. So if country D has a prevalence of 17 per thousand for disease J, what are the positive and negative predictive value? Okay, what are the positive and the negative predictive value? Okay, so I'm going to show you one of the, I have worked this one. I'll share also uh, the example. So let me just project this worked example so that we can follow nicely. Let me share also the worked example. Okay. I've seen the hand. Madam Felicitas, is your hand is still up? I don't know if you have just raised it now. Okay.
No. Sorry, no.
Okay. Yeah. So this is the question that we were looking at. Okay. Which is a screening test which is being done in a certain country. So we have this prevalence, which is 17 per thousand, okay, for the disease. So we want to find the positive and the negative predictive value, okay. So now the information that is given, follow the information that is given. Or first, before I proceed, have we understood the question, or we need to explain the question again?
You can explain it again, sir.
Okay, so we are doing a screening in a certain country, or let me say we are doing a screening in Zambia, okay. Then we are using a test kit which already have the determined sensitivity. It is given to be 80%. That means if we do this, if we use this test in Zambia, we are going to identify 80% of people who have the disease. Okay? We'll be able to correctly identify, or 80% of people who have the disease are going to test positive. Okay? Then specificity means that 85% of people who do not have the disease are going to test negative. You know that if some they have they don't have the disease, then they test negative. Those will become now false negative. Okay, so that is the issue. So now we are given the prevalence, just like we are given the prevalence of malaria in Zambia. The prevalence of malaria in Zambia is 35 per thousand people. I think, if I'm not mistaken. So we're given the prevalence of this disease, which is 17 per thousand people. Okay, 17 per thousand people. Okay, so now from this uh, information, we have to take note of the sensitivity and the specificity, also the prevalence. So from this prevalence, actually, we can maybe identify. So let's first identify. Let's identify. We have this population. The total number of people in this population are how many? The one we are given. We are going to assume that we have 1,000 people. Okay? We're going to assume that we have 1,000 people. This is the total population, right? So now you say, out of these 1,000 people, from the information that we are given, how many people have the disease? 17. Yes, 17 people have the disease. So now, if 17 people have the disease out of 1,000, how many people do not have the disease?
983.
983. So we're going to have 983. These people, they do not have the disease. Okay? Are we following on this one? Anyone who has remained behind on how we have gotten 17 and 983?
Just repeat, sir, on how you've gotten the 17.
Okay, good. So we say, in this population, we are given this prevalence here. Okay? The prevalence of this disease is 17 per 1,000 people. So that means in a group of 1,000 people, 17 of them are going to have the disease. Okay? So now, from this 1,000, we want to break it down to those people with the disease and people without the disease. So 17 are going to have the disease. We'll say these one have the disease. Okay? Then 983, they do not have the disease. Okay? So now, if we use this test with 80% sensitivity, it means that 80% of these people with the disease are going to test positive. Okay? If we are using this test, it means that 80% of these 17 people are going to test positive. Okay? So now, what is 80% of 17? How many people are going to test positive? Out of these 17 people who have the disease, how many people are going to test positive? Hello?
13.6.
13.6. Exactly. We're going to have 13.6. That is now, we are saying those who might have difficulties calculating is 80 out of 100 times 17 times 17. Okay, so it is going to give us 13.6, or we can round it off to 14. Okay, so that means 14 people are going to test positive when we are using this test. And now, if 10 people are going to test positive, now the other remaining people are going to test negative when actually they have the disease. So those people are going to be false negatives. And how many false negatives are we going to have?
3.
3. Okay, so we're going to have 3 false negatives. Great. Then you go to specificity. We are told that this number, you know, okay, let's do this. I don't know if I can draw this one here. Okay. Yeah. So we have, for people with the disease, we have 17 of them. Then according to our test, we know that 80% are going to test positive. So what is 80% of 73? So when you do 80% of 73, the weight example is here. 80% of 73 is going to give us 14. Are we seeing where this 14 is coming from? 80, 80. 80% of 17.
Of 17.
Yeah, 80, sorry for that. 80% of 17 is going to give you 14. Have we done that calculation? Have we known where 14 is coming from? Okay. Now, if we have 17 people who have the disease and only 14 people test positive, how many people are going to test negative when they have the disease?
3.
3. And how do you call these people who test negative when they have the disease?
False negative.
Yeah, so we are going to have 3 false negatives. That's what it means. Okay? We are going to have 3 false negatives. So the true positive, here we put, let me do this. Is that a hand? Madam Brenda, yes, you can ask.
Yes, sir. I'm a little bit behind on the false negatives. So on these 3 you are talking about. So maybe you can explain more.
Okay. So you remember the example that I was giving in the morning? We said we have 10 people who come to a health facility. These 10 people have the disease. Maybe they are all, but they have malaria. But you being a nurse, okay, who is in charge that day, okay, you send these people to the lab. They go, they do malaria test. Then when they come back, you only have 7 with positive results. But all these 10 people have the disease. But only 7 people have come out to be positive according to the test conducted at the lab. Okay? That means out of 7, out of 10, 3 people are going to be negative. But now remember that even these 3 people have the disease. So these people, we call them false negatives because they have the disease. It is false. This test is not correct. Okay? Are we together on this one, Madam Brenda?
Yes, I'm following.
Yes. So now this same applies to this number we have. We are given that the prevalence of this disease is 17 out of 1,000 people. So that means 17 people have the disease. Okay? Now we are given the specificity, the sensitivity, I mean. The sensitivity is 80% of the test that we are going to use. So the test that is going to be used at the lab is going to identify 80% of people who have the disease, or 80% of people who have the disease are going to test positive. Okay? So now we calculate what is 80% of 17. You can calculate that one. What is 80% of 17? Find that one. Huh?
I don't have a calculator, so I'm using my phone. Is it 13.6?
Yeah, 13.6. So now in about statistics, we cannot count people as 13.6 people. We need to round it off. So we'll go for 14. So 14 people out of 17 are going to test what? Positive. And now remember, all these people have the disease. That means that subtract now 17 minus 14 is what?
3.
Is 3. So these 3 people, even though they have the disease, are going to test what? Negative. And we are going to say these are false negatives. Are you seeing now where the 3 is coming from? Yes. So now we are done on sensitivity. We have identified that 14 people are going to test positive and 13 people are going to test, no, 3 people are going to test negative even when they have the disease. So now we'll go back. We now want to find to apply the specificity to this scenario. So we have 1,000 people. Okay, we have 1,000 people, and we remove 17 who have the disease. So how many people do not have the disease? When we subtract 1,000 minus 17, 983. Okay, so now 983 people do not have the disease. These people are not sick. Even if they feel like they have malaria, they don't have malaria. Okay, so now what, according to our situation, what is the specificity of um, this test kit that we are using? 85%. So it is good. Out of these people who do not have the disease, 85% of them are going to test negative. So now find 85% of 983. What is 85% of 983? 835.5, which is here. So now, if only 8.535, this is more like 8 36, right? 836. So now, these people are going to test negative. The remaining are going to test positive when they actually do not have the disease, but are going to test positive. How many of them are going to test positive? So subtract 983 minus 836. It's giving us what? 147. Great. It's giving us 147. So this 147 are going to test what? Positive. These will be false positive. So here, false positives, we have found them here. We put them here. So the true positive are 14. Okay. Then the false positives are what? 147, right? 147. I've started from somewhere. 147. Okay. Then the true negatives is 80. 35. Yeah. Or 80 36. Okay. Then the true, no, the false positives. Is it here? The false positive. The false positives are, okay. Where are they? Where are we? Where are we? Yeah, there are 3. Okay, there are 3. So now we can go back to our formula.
The 3 supposed to be on the other side.
These are false what? These are false negatives, right?
False negatives are supposed to be on the other side, and the 8 supposed to be on the other side.
Which one?
The 836 supposed column. Then the 3 is supposed to be in the first column.
Okay. You want it to be here? Or see what I've done now?
The 14, then at the bottom is supposed to be 3 there.
Okay. Yeah, let me do this. Here we put 3. Then here we put 836, right? I want to write it in the way that you won't get lost. Then down we put 147, right? That's what you mean, right?
I don't know for others, but I think the 147 is supposed to be on top, then the 836 at the bottom as a true negative.
So we are going to have
Very true.
this one are true what? True positive 14. Then here it's just for you now to put information so that you don't get lost. These one are going to be true negatives here. Okay? Then this side here 3 is going to be false. Uh, eh, you people have started confusing me now. I think the way I had put it at first it was okay. Because these now become negatives. So this side I want to have negatives. This side I want to have the false positive, the false negative, and the true negative. Then this other side I want us to put the true positives. Okay, Madam Merod.
I was just trying to say the top row, the first one should be a true positive, then the next one should be a false positive. Where there is 180 something, we should put 147 as a as a false positive.
Okay.
Then the true negative comes down.
So yeah, let's what time are you having the other class?
It's 20 hours.
20 hours. So can we still continue?
Yes.
Okay. Yeah, so let me remove this table here. Or maybe we can use this table which is given here so that we don't get lost. Yeah. So we have this table. So according to what we were given, the true positives, I'll do this here. The true positive here was what?
14.
Yeah, let me write it here on top so that we can follow it properly. The true positive is 14. Okay? Then the false positives,
147.
147. Yeah. Then the false, is it false negative? 3. Yeah. Then the true negatives, 80, 30,